Here we are going to discuss about what are the conditions for constructive and destructive interference. When we can say that the light coming from S1 and S2 will have or will be a constructive interference at a particular point, and when we can say that will be a destructive interference. So to know that condition, first of all let us revise one more way, that is when there is a maxima or constructive interference and when there is a minima or destructive interference. Suppose a light is coming from this S1 source and the light coming from the S1 source in such a way that crust of this wave lies on the crust of this wave, that is light coming from the S2 source. दोनों की crust सुपर इम्पोज करे और दोनों की ट्रफ सुपर इम्पोज करे इस पॉइंट पर, then this point will be having maxima, or we can say that this is having a constructive interference. So to have a constructive interference, there should be crust should lie on the crust or trough should lie on the trough. Now for the case of destructive interference, suppose the light coming from S1 source and the light coming from the S2 source, when reaches to a point or both superimpose in such a way that crust of one lie on the trough of other, then this is a minima. This point will have a minima, and this type of interference is known as a destructive interference. Here, what should be the distance? What should be the distance between S1 and S2 so that there will be a maxima or constructive interference? Similarly, what should be the distance of S1 and S2 so that this point will have a minimum or destructive interference? Now, both the phenomena can be understood from this diagrams. So, I have already drawn these diagrams, but first, what is the condition for constructive interference? What should be the distance of this source? Suppose, now I am going to discuss about the condition for constructive interference. Now, see this first one diagram, see this first one diagram. Here, the light is coming or a wave is coming from this source S1 and from the source S2 and reaches to this point in such a way that the crust of one, that is S1, lie on the crust of other one, this one. So both the crust lie at the same point. So when the crust fall on the crust, then this point is of maxima or having a constructive interference. Now I want to know that what is the path difference between the source S1 and S2. So first of all, let us discuss it. I want to know this, what is the path this S1O. So I will calculate a path in terms of wavelengths. If I draw here, this is one wavelength. From this point to this point, it counts one wavelength. We represent wavelength by lambda. So similarly, I will count the distance in terms of wavelength. Now see here, from this point to this point, this is counts one wavelength. Similarly, this next one to this one, this is your second wavelength, two wavelengths. This is your three wavelengths. And here to here, it is your three wavelengths. So I am having three wavelengths complete. And from here to maximum. This part of the wavelength, is extra. So mean to say that from mean to maximum, from here to this maximum, what should be this wavelength? What should be this distance? So we know that this distance from here to here, this distance is half of lambda by 2 and this distance is half of it. This distance will be lambda by 4. So what should be the S1 co-distance? It is 3 lambda plus lambda by 4. Similarly, I want to calculate the path S2O. Now see here, same manner. So this is our first one wavelength. This is our two wavelengths. This is our third or three, and this is our four. So we have four wavelengths. So this is 4 lambda. Now similarly, here it is from mean to maximum. Mean to maximum. This is lambda by 4. So it is lambda by 4. Now I want to know what is the path difference. So here the path difference, that is S2O minus S1O, is comes out to be, if you calculate difference, lambda by 4 cancel out, 4 lambda minus 3 lambda, it is coming out to be lambda only. So this is known as a path difference. The difference of the path of source S2 and S1. So we represent it by delta x. So path difference is coming out to be, in first case, is by lambda. Now I have displaced this source by a displacement equal to lambda. मैंने इस सोर्स को लैम्डा डिस्टेंस से डिस्प्लेस कर दिया, such that इस तरह से डिस्प्लेस करना है कि इसकी क्रस्ट यहां पर लाई करे and this point will be a maximum. So now what is the path difference in this case? So here you can see that the position of S1 is fixed. So S1O will be same, that is 3 lambda plus lambda by 4, and the distance S2O will be equal to how much? 1 lambda, 2, 3, 4 and 5. It is 5 lambda plus lambda by 4, because from here to here it is lambda by 4. So if you calculate the path difference, that is the difference of the sources from the observation point, that is S2O minus S1O is equal to be 2 lambda, because lambda by 4 cancelled out. So 5 lambda minus 3 lambda is equal to 2 lambda. Similarly, if you displace this source in such a way that the light coming from this source have a maxima at this point, means crust should lie at this point. This can only be possible if you displace the source by one more wavelength. So again, you will have here 6 lambda plus lambda by 4. So you will find that in that case, the path difference is coming out to be 3 lambda. If you generalize all these one, you will find that combining all, what do you got? We got that whenever my path difference of S2 with respect to S1 is lambda, 2 lambda, 3 lambda or so on, then there is a constructive interference or maximum. वहां पर constructive interference होगा या maximum. Both are constructive interference or maximum. So if you generalize this, or you write this path difference in the general form, so what do you get? So you get the path difference, that is delta x is equal to 1, 2, 3. So it is n lambda. So whenever your path difference is equal to integral multiple of wavelength, where n can be 0, 1, 2, 3 and so on, that whenever there is a path difference is equal to integral multiple of wavelength, then that point will have a constructive interference or the position will have a maximum. One thing I have assumed that the light coming from the source S1 and S2 have a same wavelength. Let us discuss about now the condition for destructive interference. What should be the path difference between S1 and S2 so that this position will have a minimum? Now for that I have drawn a simple diagram. Suppose the light coming from this source S1 and the light coming from this source S2 in the form of wave and reaches to this point O. We know that when the trough of S1 lies on the crust of S2, then this point will have a minimum destructive interference. So I want to know that what should be the distance of S1 with respect to the S2 so that this position is having a minimum or destructive interference. To do it, I will calculate the path difference in terms of wavelength. So again I am drawing it. So this from this to this one, this forms a one wavelength. This part of length represents half of wavelength, and this part from here to here, mean to maximum position, and this part of the wavelength will be equal to lambda by 4. Now let us count the path difference, that is S1O and S2O in terms of wavelength. Now see here, for S1, see it is one wavelength. This is your second wavelength, and two wavelengths are complete. So it is 2 lambda. Now next one is here, to have a wavelength, it should be here. Mean it is, this part is less, or you can say that from here to here, that is half of wavelength, and it is lambda by 2, plus this part from mean to maximum, that is this part is here lambda by 4. So what it becomes now? So it will be lambda by 2 plus lambda by 4. I want to calculate the path S2O. So see here, this is your one wavelength, this is your second wavelength, and here it is your third wavelength. So 3 wavelengths are complete. Plus from mean to maximum. So mean to maximum means lambda by 4. So it is lambda by 4. Now I want to calculate the path difference. So it is S2O minus S1O. Now if you put the value, so see here, 3 lambda plus lambda by 4 minus 2 lambda minus lambda by 2 minus lambda by 4. So this lambda by 4 can cancel out, and minus 2 lambda. It is lambda minus lambda by 2. So if you solve it, it comes out to be lambda by 2. So this difference S2O minus S1O, it is nothing but it is a path difference. So we represent the path difference by delta x. The path difference is coming out to be lambda by 2. So when your path difference is half of the wavelength, at this point, when the path difference means the light coming from the source S1 and the light coming from the source S2, दोनों में path का difference जो है, अगर वो lambda by 2 है, then this point will have a minimum or destructive interference. Similarly, if I displace this source S2 in such a way that this point will have a minimum, this can only be possible if you displace this source by a displacement of one wavelength. अगर इसको one wavelength से आप displace कर दोगे, तो you will have a minimum, means यहाँ पर crust ही रहेगी. First, S1O will remain same because I have fixed the position, that is 2 lambda plus lambda by 2 and lambda by 4. Now what is your S2O? Now here I have increased the distance by only one wavelength. So it will be 4 lambda. 1, 2, 3 and it is 4 plus mean to maximum. It is lambda by 4. Now if you calculate a difference from here, you can find that the path difference, that is S2O minus S1O, is coming out to be, from here you can see the lambda by 4 and lambda by 4 will cancel out. We will left here 2 lambda plus, so I am writing a 4 lambda minus 2 minus lambda by 2. So if you solve it, it is coming out to be 2 lambda minus lambda by 2. And if you solve it, it is 3 lambda by 2. So again, you find that when the path difference is 3 lambda by 2, then this will have a destructive interference. Now take one more case. Now I displace this S2 distance more such that this point is minimum, means इस S2 की यहाँ पर thrust आनी चाहिए. So it can only be possible when you increase the distance by one wavelength. So now the power difference S1O will remain same, that is 2 lambda plus lambda by 2 plus lambda by 4. Now what should be your S2O? S2O will be equal to how much? This is one wavelength, this is second, third, fourth, and this is fifth wavelength. Now it is 5 lambda plus lambda by 4. From here to here, it is lambda by 4. Now you want to calculate the power difference. So power difference is nothing but it is S2O minus S1O. So put the value, that is 5 lambda plus lambda by 4 minus 2 lambda minus lambda by 2 minus lambda by 4. So this lambda by 4 get cancelled out. You are left with this minus 2 lambda and this 5 lambda. 3 lambda minus lambda by 2. If you solve it, you will find that it is 5 lambda by 2. So what you got from here? Now similarly, if you calculate the power difference for next case also, it will be 7 lambda by 2. So if you see carefully, whenever your power difference is lambda by 2, 3 lambda by 2, 5 lambda by 2, or I can write together when your power difference is lambda by 2, 3 lambda by 2, 5 lambda by 2, and so on, then this point will have a minimum. जब भी सोर्स S1 और S2 से जो पाथ का डिफरेंस आता है, अगर वो पाथ डिफरेंस लैम्डा बाय 2, 3 लैम्डा बाय 2, 5 लैम्डा बाय 2 और 7 बाय लैम्डा बाय 2 and so on आता है, then this point will have always be in minimum or have a destructive interference. Condition is that I have taken the wavelength of both the source equal, that is lambda. This in generalized form, if you write this in general form, so you see here it is 1, 3, 5, 7. So it is odd. So odd number can be written as 2 and minus 1. So the rest one is lambda by 2, lambda by 2, lambda by 2 is common. So it is lambda by 2. So this is your required condition for interference or minimum or darkness.